we have three different computer screens here that actually do three different things. So on the far left here is what we call our text workstation. And so that's where we do the writing part of it, where we can look at specific text-based products, and then we can also, we have to write out our forecast discussion at the end of the day. If we have to write warning products, if we have to put out winter storm warnings, that's where we kind of type all the text. So that is basically both in and out. And where we do the aviation forecasts, we do very specific forecasts for the airports. And then basically on these two big screens, kind of think of it as one is the weather models and data that's coming in. And then this one we call the graphical forecast editor. So this is where the forecast that you get, where I create this and it goes out. So we can kind of start over here on the left. So we can have a million different kind of things up here, but in general, we kind of have, like this is the satellite image of what's going on right now. So these are from our geostationary satellites up at 22,000 miles away. And so this is giving us kind of a constant overview of exactly what's going on. And then on a smaller scale, a lot of times what we do in the weather is we kind of what we call a funnel. So we start at the very top, looking at the very big scale things that are going on, and then we kind of look smaller and smaller down onto where we're at to get an idea of what's going on. So the next scale down, we have radar image. So this is from our weather radar that's out on Virginia Peak. And then it also has you can look at all the other radars that are around the region so we can see what's coming towards us. So the radar shows the precipitation that's falling out of the sky, so we can see where it's raining or snowing. And that's really helpful. We can see storms developing, and that's where we do, if we're doing any sort of summertime weather, convection kind of thunderstorms, those kind of things, that's where we do all those kind of warning products out of. And it's the one kind of interesting thing is the winter and summer are very different as far as the pace of it. In the wintertime, we're trying to look out, a couple of days in advance and putting out products, we're expecting a snowstorm. In the summertime, things can happen much faster with thunderstorms. They can develop very quickly and create problems, in tens of minutes instead of hours. So it's a much faster pace, very different kind of weather, very different kind of products that we have to issue. So it's definitely very interesting to go from season to season because they are pretty different. And then we have all sorts of different weather models. We have, and we started kind of the global weather models. So there's a couple weather models that cover the whole globe and kind of show us where high and low pressure weather systems are at and where they're going to be in the future. And then we have a lot of different kinds of weather models. So we have ensemble weather models, which is a complex, basically shows the realm of possibilities by running weather models a bunch of times at a little bit lower resolution. And so we can kind of see like the range of possibilities. And then we have very high resolution forecasts models that are, down to, less than a mile of space that they can tell us what's going on. And those models have definitely really developed over the last couple of decades, where what we can see now, I can't imagine trying to forecast the weather without what we have now. So that's really interesting. So we can look at all sorts of different weather models. We can look at the different, let's see, I don't know if you can see quite well enough here to see the different screens. Maybe I can give you a little closer look. I'll try to do this. Let's see if that work. Okay. So on this weather model, basically this one's showing the very upper atmosphere where the jet stream is. So this is showing the different speeds and angles of the jet stream, the 500 millibar heights, and this is where we really determine where the large scale high and low pressures are. And then this one is about at the ridge top, the mountain ridges for us, so right about at the Sierra crest. And this one shows the wind and temperature, and that gives us a really good idea of snow level and the amount of wind that we might get at the surface. And then on the bottom left, we have the surface wind and pressures. And so as we can kind of go through time, we can step through and see how that model is expecting things to move throughout the days and the hours. And in our computers here, we can really zoom in really close and really see things very, very high resolution, which helps us with the forecast here. One of the interesting things, a great quote about weather models is, one of the things you have to understand is that they're just a depiction of what might happen with our best estimate to begin with. And so one of the great quotes about weather models is, all weather models are wrong, but some are useful. So what that basically means is that we can't predict the future perfectly when it comes to weather. Predict the weather this well, I think, is really absolutely amazing. There's an important theory called chaos theory, which says that really dynamic systems like the weather are only very determined by their initial conditions. So exactly what the atmosphere is doing right now, very small changes in that could have really dramatic effects down the line. And one of the interesting things is that we actually can't measure the weather all that well. If you think about it, we have all these satellites and radar and ground surface stations, but when you think about how far away some of those surface weather stations are, and close ones are 5 or 10 miles from each other, and who knows what's going on in between there. And so it's actually really amazing that we basically have like a limit of, even when we have more and more information and the best computers in the world, we're still going to have a really hard time predicting the weather farther than a week or two out, which I think is kind of fascinating. So we take all that information, usually on a normal shift, we come in and we do work 24/7, which is something that they failed to mention when I went to school for this specific job. So we do have to take turns working at nighttime. When we come in, we'll get a briefing from the overnight crew, and they'll tell us what they were looking at, what products they put out, what's going on, maybe what to look for in the upcoming shift. And then we look at all the weather models. We have a ton of different weather models, both on our cool computer system here, but also on the internet. There's a lot of other complex tools and weather models that we can look at there that can help us get an idea. And then it comes to actually creating the forecast. And so if you ever go to our website and click on your area, what you'll see is a little green box over your town, and then it'll give you on the map, and then it'll give you the weather. And so basically on here, that's what this is. This grid is basically each one of these points is one of those grids. And so turn off this alarm real quick. And so we also forecast for a ton of points. Like if you look in here really closely, like each one of those ones that has a number on it is one of those points, but there's also all these other points too that you could click on and get a forecast for. I can't quite see that. There we go. So there's all these other points that you could click on and get a forecast for. And in our forecast area, which is just the Sierra and Western Nevada, we actually have tens of thousands of forecast points. And at each one of those points, we're forecasting when it's going to rain, how much it's going to rain, whether it's going to be snow, what the temperature is going to be, what the sky, whether it's going to be clear skies or cloudy, all these different things, the wind direction. And so when we do that, we can't forecast ourselves for that many different points as a human. So we have to use computers. And what's really interesting is this is kind of a real melding between computers and humans working together, where we have these different tools and different information, and then the human is able to kind of take some of that stuff and kind of mix it together and get it into a way where we can actually have a really good forecast for all these different points, which is kind of a little bit of art mixed in with a lot of science. And so that part's really interesting. And so all of these are what we call, sorry, I keep getting some alarms on here. All of these grids, these are what we edit. So we have, like I said, the maximum and minimum temperature. And if you click on each one of these, we'll get a whole different screen over here of the different, of those different numbers. And then we have the wind and wind gusts and, like I said, the sky and the probability of precipitation. What's the chance that we're going to get any precipitation? And then if we do get precipitation, how much and what the snow level is going to be. So we go through and we look at each one of those, and we look at the weather models, and we look at this system also has models in it as well that are created just for these grids. And so I take all that information and we do the best we can to put that information together into a reasonable forecast. And then we decide whether we need to put out any watches or warnings based on those forecasts and how it's going to impact society, whether it's going to be a big snowstorm that we need to let people know ahead of time so that they can change their travel plans or prepare. And then once we put out those products, then we write a forecast discussion, which is a public product that basically says why I did what I did, why I put out the winter storm warning, because it's going to be this much snow and it's going to impact this area during this time. And then we'll put out all those products and then brief in the next shift to get ready for their evening shift.